A fifth technique that you can do is using a conjugate. So for example, if I had the expression 1 over 1 plus the sine of theta, the conjugate is 1 minus the sine of theta. So I multiply both the numerator and denominator by 1 minus the sine of theta. My top 1 times 1 minus sine theta is just 1 minus sine of theta. If I were to then FOIL out my denominator, here I've got a difference of 2 squares, which means I'll have 1 minus sine squared of theta. And you might not think that helps us too much, but 1 minus sine squared of theta is actually a Pythagorean identity. It's going to be the cosine squared of theta. And if I can simplify something down like that, that could help me further down the road in a complex problem. So if I see an opportunity to use a conjugate, I might want to try that. Number 6, use your Pythagorean and or other fundamental identities. If you see something that's a pi over 2 minus theta, the only thing you know for that is a cofunction identity. So substitute that in and simplify. Or if you see a tangent of negative theta, the only thing you know to do with that is to use your even or odd identities. So take care of those right away if you see them in those problems. And then number 7 is always try something. If you see a setup, you're going to want to analyze for one of those specific 6 pieces. But if there is nothing that you know to do, just convert everything into sine and cosines and then combine together. That's really the best route that you can take. So a couple of examples that we have. First of all, we've got the one substitution step to simplify. And this sort of goes back to number 6 that I just talked about. Cotangent of pi over 2 minus x. Right here we've got a cofunction. So we want to simplify our cofunction right away. And if I look back at my previous page here with all my identities, I've got the cotangent of pi over 2 minus x. Same thing as the cotangent of pi over 2 minus theta. That's the same thing as the tangent of theta. So I know that this piece right here, this cotangent of pi over 2 minus x, is going to be the same thing as the tangent of x. And then I've got the cosine of x. Now that's not fully simplified yet. Tangent, I can then write in terms of sine and cosine. Tangent is the sine of x over the cosine of x times the cosine of x. Since I'm multiplying those two pieces, simplify, and I'm left with the sine of x. So cotangent of pi over 2 minus x, cosine of x, is the same thing as sine of x. The second one that I've got right here involves even odd identities. The fact that both of these negative signs are on the inside lets me know it's going to be either odd or even, and I've got to pull out that negative or make it go away. Cotangent we know is an odd function, so I can pull that negative out in front. Cosecant is also a negative function. I should say an odd function. So we'll pull that negative out in front. So now I've got two negative signs out in front. If I divide two negatives, really all I've got is this positive expression. Not fully simplified yet. I can convert everything to sines and cosines. So cotangent in terms of sine and cosine is the cosine of theta over the sine of theta. And the cosecant we know is 1 over the sine of theta. My sines cancel out, and I'm left with the cosine of theta. So the cotangent of negative theta divided by the cosecant of negative theta simplifies down to the cosine of theta. Second example that we've got here is dealing with a monomial that we can factor out. Here, secant squared of theta, tangent squared of theta plus secant squared of theta. I've got a common secant squared in both pieces. So I'm going to pull out a secant squared of theta. And then I'm left with tangent squared of theta plus 1. At that point, I got to ask myself, am I done yet? And the answer is no, I'm not. Reason is because right here, tangent squared of theta plus 1, there's a Pythagorean identity. Tangent squared of theta plus 1 is the same thing as secant squared of theta. So secant squared times secant squared is going to be secant to the 4th of theta. And at that point, I'm fully simplified. I didn't write in terms of sine and cosine because 1 over the cosine raised to the 4th of theta, that's more messy because I've got a fraction. So I just want to leave that in terms of secant raised to the 4th.